Deploying a machine learning model in production is a fundamentally different thing than deploying regular software in production. Any organization serious about machine learning needs to have proper procedures for change management and a way of monitoring those models while they're in production. In this episode, I speak with Piotr Niedźwiedź from Neptune.ai. We explore the current state of MLOps, experiment tracking, and how organizations of all sizes are achieving success.
My name is Piotr Niedźwiedź, co-founder and CEO at Neptune.ai. At Neptune, we help data scientists and data science teams, organizations to track and manage their machine learning models' metadata.
Well, obviously, we're going to get into some details about that, but I'd love to hear a little bit about your background. Where's the first line of code for you?
Oh, it was early. I was 7. It was in basic. So engineering is my, I would still say, number one background. After I started coding early, as I said, then I got into classical algorithms. I was starting from high school, and during my university time, I was doing a lot of competitive programming, and with some global successes on Google Code Jam competitions, top coder. I graduated from double degree program in mathematics and computer science, but I also have entrepreneurial background. I can say it's after 2 internships I did. It was in Google and Facebook. I got enough money to establish my own company. It was something like 13 years ago. Long story short, besides Neptune, I co-own 3 companies. In total, there are over 600 people. All the companies are in tech. Those companies were self-founded. So you can say that it is, to some extent, reasonable scale success business-wise, but not, of course, Google type of success.
Well, we heard about when you started with code. When is your first introduction to machine learning?
It is a good question, because we would need to set here a boundary between statistics and machine learning. So this boundary is not so clear for me. Something like 16 years ago. Of course, it is hard to compare what is possible today, but machine learning, the foundations are rather older than a few years.
The earliest days, machine learning was very custom. First of all, there weren't any tools or platforms just yet, and everyone was kind of investing a lot of time in reinventing the wheel. Then, of course, we got libraries and the field progressed and things like that. But I'm curious, since you see and interact with so many people who are using your platform, obviously, there are a bit more standards. It's not quite the Wild West, but what is the current state? Are people centralizing on a standard tech stack for machine learning, or do you still see a great variety?
Definitely the change versus 16 years ago is that today there are a lot of options. From one perspective, it is great. On the other hand, it is pretty problematic. From high level, if you are a data science team building models that you want to eventually as a business operate on production, I would say there are 2 options on high level. On one hand, you can go and buy one of end-to-end machine learning platforms. They provide almost everything. The alternative approach, an approach that I need to admit that I am biased towards because I think it is closer to software engineering, is approach of building your tech stack from best-in-breed, best-in-class tools. Today, the challenge with building your tech stack is that for me, a person who is following this market on a daily basis, it is quite challenging what tools, what products you should use and how they work together. Because today there are too many, we do not have clearly defined categories in MLOps space. But I think it's getting, definitely, if I compare situation today versus 3 years ago when we were starting and we were having at Neptune, we had hard time to explain what we do. Today, it is order of magnitude easier because we, as a community of people in this field, we started to establishing some common vocabulary and started naming things, but it is still in progress.
Well, when is the right time for a new startup to engage with a tool like Neptune.ai? Let's say we're going to dabble in some machine learning. Do I start with you day one, or do I have to hit a certain milestone?
I would start from day zero. Day zero, assuming that day zero is the day I start to develop, train machine learning model. Of course, day zero in practice is firstly, you need to know that you have a problem that can be solved using machine learning techniques. And it's worth solving yourself, right?
Very good point. Yeah.
Because I am a big fan of buying what you can buy and building what you really, really need to build that make you different, that is essential to your business. Because very often, like the problems that you may think, yeah, maybe some artificial intelligence would do some magic, very often those problems are not machine learning problems, or those problems can be solved using already existing tools, libraries, APIs. So it is the very first thing, like define the problem. Then, of course, it is hard to apply machine learning without data. It is the next stage. But once you get to the point that you know that you are dealing with a problem that is important to your business, you have relevant resources. I talk mainly about data, and you are committed to create a machine learning model to solve it. This is day zero for Neptune. It is super easy to start. It just think about Neptune at the beginning as a more sophisticated print function in your code. So instead of printing stuff to the console and losing it, you will print it. Of course, it is sent to Neptune servers, visualized. It is more richer than just logs. But you will start logging things, tracking things, not losing things from day zero. I think today some people may say maybe it's too early. I remember it was maybe 13 years ago. I remember discussions on Stack Overflow about similar question, but to software. When you should start using Git or other version control system.
Oh, day zero for sure.
Yeah, exactly. Why? Because it helps you not to do the same things many times and help you get more organized. But at the same time, it is not so hard. Doing this Git commit, Git push is not a big task to and practice to follow. So day zero.
Well, your comparison to a print statement, I think, is a useful shortcut for someone who develops code and develops models, because they get that. I'm constantly printing things out, and as you say, they're lost. But we've always had like logging tools where I could just send arbitrary messages and they're stored in the cloud. There's a lot more features, especially aimed at machine learning development. What are some of the things people can take advantage of?
Or maybe in machine learning, it would be the first thing to log, would be the evolution of your training metrics that would help you understand how your training is doing, whether your model is getting better or not. You will also would like to log reference to your code. You can log code, but I'm talking about maybe Git reference to your source code. You would like to log reference again, not the data set, but reference to your data set in order to know what data you use to train this model. And of course, like it is now all depends on the problem you're working on. But if you are working on some image processing, quite likely you would like to log information about like some debug images from different epoch of your training. Of course, hyperparameters, so the parameters that you want to change, testing different model training versions. Yeah, those would be the first things that comes to my mind.
Yeah.
Very often people also log snapshots of model weights from different epochs from time to time, just to be able to kind of get particular model version, or if they're using spot instances, so trying to save money on compute, being able to resume training of a model. So there are a lot of I would say special types of data that are a little bit more rich or even significantly more rich than the standard logs that you would like to log during when you're running software.
Well, when I think about times I've been in a software engineering role, typically if I'm looking at my logs and metadata, it's because I have a bug. I'm trying to trace down a problem. Or maybe once in a while I want to reduce the latency, but usually it's reactive. Whereas I think as a data scientist, I really want to take a whole different approach. Technically, all this is just logging data, but it seems like a much more interactive process. Could you compare and contrast a little bit between how software engineers use logs and how data scientists do?
Sure, like you're absolutely right, but I would, so this context is different. The difference, I think the difference comes from amount of iterations. Like very often when you code something, of course, it all depends on on the skill set and how hard thing you code, but very often you're not getting it right at the very first iteration. Like I'm initially it doesn't compile, okay, then it compiles, but but quite likely doesn't work, you have bugs, it doesn't pass the unit tests, but in a day or two you're good. That's why you don't spend so much time on debugging, comparing, looking at the logs, because it is way easier in software to have a plan, like to have a plan at the very beginning before you start coding a function, a class, how it should work. And usually it works like you thought. In data science, you really cannot know. Like we don't know. We have intuition, but it is statistics. You need to prove it. You need to test it. That's why before you get, when you're working on a new model, before you get to the level of the quality that is acceptable to be moved to production, you will run hundreds or thousands of experiments of trials, and you are in the debugging mode, or debugging, looking for improvement, because debugging sounds like you have a bug in the code, but here it is not about bugs most often, or maybe equally often, but also about what sometimes people call meta ML. So about finding the ideas how I can, like what I can change in this architecture in hyperparameters. Okay, you can always do hyperparameter optimization, but still you have to limit it to some space. Otherwise, quite likely, otherwise you don't have resources to try every potential permutation or setup for your hyperparameters. So it is way more iterative process. That's why you need debugging more often. So in this context, you're absolutely right. But there is a second context where that I would say is pretty common to software and to data science. The context is closer to production. And then, like, it is hard, at least for me, it is hard to imagine to have software on production and not to have any monitoring system. Once there is some bug on production that can be caused by things that we didn't predict during writing the tests or we have not observed so far, it's rather safer to be able to understand what happened, right? To have those logs. In software, it is obvious that you need those logs if you want to operate software on production in order to fix it later if you observe something that caused problems. In data science, you also need to track, you need to monitor your models on production. And I'm not only talking about drift of your inputs, outputs, I'm also talking about more software related aspects you monitor, because model on production is in fact a piece of software, right? So in this context, you will need those logs more retroactively, like in software.
When I'm going through that iterative process, building up a machine learning experiment of some kind, there's a lot, like you say, I'm looking for insights. What do I need to tweak? What do I need to improve? And that path, I can definitely understand how experiment tracking helps me. I'm curious if you look outside of just one practitioner, do you see teams finding good ways to collaborate and organizations to have more transparency through tools like this?
Definitely, it is easier to share something in order to discuss, because you can just grab a link to your training process, pass it over Slack, and somebody can go check hyperparameters, code, learning curves, how your model was doing. Maybe the person can help you debug or provide you some idea for improvement, can compare it with her work, because very often, like after I remember a practice that it was a few years ago, we were competing on Kaggle, and we had a practice. We were a team of three. Every week we had a sync up where we compare like our best models, and explained how we did it. And the next week we usually started from the few best models. 2 out of 3 people were picking up someone else's model, training code, and try to iterate from it. So it helps. It's in a team. It is helpful in a team, but I think it is even more fundamental if you think about the whole organization. Because when it comes to whole organization, if you don't have a place where you have all the okay, I will use this word, metadata about your machine learning model's lifecycle, it is pretty risky. On one hand, you may be losing, like if someone decides to leave your company, that in this field is happening from time to time. You may lose a lot, like you will lose a lot anyway, but at least you will have some artifacts, some models in a way that you can pick them up, and if needed, you understand the whole lineage. Quite likely you know how to retrain the model, how it was built. From this perspective, it is important. It's very important actually if you are thinking about operating models on production, because from technical point of view, it is not so problematic, because it is not so far from how we operate. There are differences, but not such significant difference, in my opinion, to how we operate today software using DevOps practices. But the challenge is in the confidence that that the model that was built, this model is something that should be on production, that you really know what was the data, whether it was properly tested after training, whether it was, if it all depends on the use case, but you would like to see that this model pass your quality checks. I don't want to go into legal aspects. In some fields it is a must-have to for auditing perspective, but I prefer to focus on just technical, or looking at this set of problems from tech perspective.
Yeah. One challenge I've had in delegating a little bit is that, someone else could take over a model I've built, and when we want to do an update, things could go wrong. Maybe that they sent me the wrong model binary, or it's using the wrong features, or lots of just different communication issues could go on. Are there ways in which these processes can help make kind of less production mistakes like that and give me more of a confidence that I know what's going
It
in?
of course helps you organize yourself as an organization. We at Neptune try to be like, okay, we won't force you to get organized, because if you try to force somebody, quite likely you will need to limit somebody, and it is something that we don't want to do. But you can establish, I would call it, a protocol of collaboration within the team of data scientists, between data scientists and ML engineers, between ML engineers and DevOps engineers. And in software, in most cases, it is like that. If someone wants to do something bad, quite likely, unless you are really sophisticated, big organization that has a lot of checks, it is hard. But in most companies, if software engineer or DevOps engineer would like to do something, quite likely he would succeed. But most people are not like that. And it will help you establish a clean protocol of collaboration, definitely.
Well, as a machine learning practitioner, I have a number of tools I could pick. I could use some open source things like sklearn myself. I could build it in Spark. I could use a commercial tool like SageMaker. How does the Neptune experience work in all of these different settings?
In most cases, it works out of the box next to it. We are not end-to-end platform, right? So we are not here to replace your stack. I think it is too complex, and there are too many smart people in the field. So we don't even have such an ambition. We are a component that integrates with pipelining frameworks. We are integrated naturally with different options for data, like data storage, data processing, of course, of all the machine learning frameworks. If you go and play with Neptune, you will figure out that it is pretty simple. Maybe a little bit more complex than print statement, but not so much.
Yeah. Well, in order for you to get wired into an organization, you have to have some advocate on the inside, someone who says, I want to use this tool. Does that tend to be the machine learning practitioner or their manager or C-level? Who's the first to say, let's use it?
Of course, it depends on organization. If it is small startup, C-level is hands-on person like
Yeah.
at Neptune. Yeah, it's funny even to call me C-level guy. Like, but it is mostly bottom up. It comes in most cases from data scientists, data science team leads, but yeah, almost always it is bottom up. So practitioner who really understands what she does and what she needs. I think it is very hard today and a little bit counterproductive to try to approach this market going top down, going to CTOs. Like, of course, there are CTOs who are hands-on, but if we are talking about big organizations, CTOs are having a lot of problems and quite likely are, this MLOps field is too complex to follow on daily basis. And we are at Neptune, we are, in my opinion, important, but one of the components of the broader setup. So at this stage of the market development, our go-to market and our efforts are targeted at data scientists, ML engineers, team leads of such teams.
Well, in comparison to something like using source control, it would be shocking to me if a serious software group wasn't on it. Git or SVN or whatever, you have source control. I would think it's 100% adoption. I don't think we're at 100% adoption with experiment tracking and model registry. Do you have a sense of where things are at in the growth life cycle?
I think it is not so obvious. Like, eventually, of course, bigger players will play in this field as well. Of course, I hope that Neptune at that time will be a bigger player. But I think that from today's perspective, if you look at, let's think a little bit about GitHub, GitLab, I would say that there are players for, there are not only source control systems, there are more today also in dealing with task management, issue management, and even primary. That I think the direction is to go deeper into CI/CD processes. So I
Mm-hmm.
think there are a lot of work here. To some extent, it will be because I think that MLOps has to be closely integrated with DevOps. Because if you are releasing, even when you look at the model, if you are releasing the model with a little bit different assumptions around data, your application, like inputs and outputs signature, your application also needs to be aware of that. So sometimes you need to deploy, like coordinate deployment of model version with application version. So it is natural that they have to be integrated closely. But when it comes to aspects of that we are dealing with Neptune, we are quite far. Think about Datadog, Splunk, Sumo Logic, like software monitoring tools. ELK, Elastic, of course. You can say that they are capturing metadata about software, but not static form of software, not necessarily about code, but about behavior of the code, of the running software, right? That experiment tracking of the process of automatically retraining of the models, model registry type of functionality is something close, but source code is just part of the, like, it is just a metadata, like data sets. Are we going to store data sets at Git? Quite likely not. Of course, it is hard to predict, but I don't see that this should be packed into one product in the next 4 or 5 years. It is. I don't believe it will be packed.
And when teams adopt, what are some of the low-hanging fruit they achieve by turning on these sorts of services?
Instantly, they free some cognitive memory. Like team members don't need to, jump to the SSH to the console and see how the model is performing. They can see it on the mobile. They can see it on the nicely on as a chart. They very often save compute power. So those are the low-hanging fruits that comes within a week. Reproducibility is not the thing that is important in a week, because usually you remember what you've been doing this week, right? But reproducibility comes after a month.
And what about long term? What does that team appreciate 6 to 12 months out?
And it is not about Neptune. It is more about experiment tracking in general as a function, as a set of jobs that tools like that are doing. I heard a couple of times from people who have not been using tool like that and use it the first time, that it is no go back. And they said that they feel that things are under control, finally. It is this kind of a comfort that it is not so easy to break things. I would say it this way. Like in source version control, I try to find an analogy to source version control. There is one aspect that is not necessarily so relevant in MLOps space, is that source version control comes with two things. Like one is the backup, but second, quite likely even more important, is merging. Without source version control and merge functionality, it is almost impossible to build bigger software as a team together. Yeah, because it was hard to merge stuff. Source version controls and merge functionality help here. In data science, we are not necessarily merging. Okay, you can always do some model and thing, but it is not this way of merging. So I would say that in the long run, it is this confidence that you know what is happening, how things were done, you know that your team established a protocol of collaboration, besides, of course, some efficiency benefits on daily basis.
Can you tell me what you mean? I'm not familiar with the phrase reasonable scale MLOps.
It is all about, I would say, simple observation that 99% of the companies are not doing machine learning at hyperscale like Google, Uber, Airbnb.
Right, for
So
sure.
it is simple observation, right? But at the same time, most of the good blog posts, like really good blog posts, white papers, conference talks, are created by people working in such companies and showing like what incredible job they are doing. People are then trying to apply some good practices, how we should go with tech stack, with processes around operating models and production. They're naturally biased toward hyperscale, but they are not even close to Google, have different needs. Yeah, there is a lot of over engineering in the field.
Yeah. I mean, the average, small business that could benefit from machine learning in production, they don't need to do so at 5,000 transactions per
Yeah,
second.
it's even not like we can call small, but medium level, even medium level. When
Yeah.
you are processing millions of transactions on daily basis, it is still not so huge, and you quite likely wouldn't need to retrain your model every 8 hours. A lot of things can be way simpler. So not necessarily, going with the architecture, good practices coming from the biggest players, quite likely is not a good idea for most.
So does that open opportunities in the market for a team to help with solutions that are more addressable for everyone else?
I think that definitely, we are trying to do that, not only by tool and by our product. We are pretty active when it comes to our blog. Try to interview some of our customers, but not only reasonable scale teams, and try to understand and ask them, okay, how your tech stack look like. Usually those guys know how big guys are doing, and if my stack is way smaller, it sounds that, well, it is not so impressive, but actually it is super useful because it is what most teams need to understand how similar teams were dealing with similar problems.
Well, that sounds like a really good resource. We'll have a link in the show notes, but for listeners at their terminal now, it's Neptune.ai/blog. Well, Piotr, thank you so much for taking the time to come on and share your experience.
Thanks a lot. It was a pleasure.
That's it for today's episode. The main reason a lot of people run experiments in production is because they have great uncertainty about the future.
There are different kinds of queries arriving over a period of time. Future is unknown, uncertain. And when, let's say, a platform wants to make some decisions about ads, it doesn't really know what's going to come in the future. So that's really where my interest arises from. It's more from the mathematical connection with these problems that I'm interested in.
That's next time on Data Skeptic Ad Tech.